Alrighty, let's see what we got here. Find the number of ways to place people, part 1. You're given a 2D array of points, size n by 2. Represent integer coordinates of some points on a 2D plane where points of I is x sub I, y sub I. Count the number of pairs of points A, B, where A is in the upper left side of B. There's no other points in the rectangle or line that they make, including the border. There are no other points, including the border. Okay. So if the points are 1, 1, 2, 2, 2, 3, I guess the coordinates are kind of in the first quadrant type deal. So 0, 0, 1, 1, 2, 2, 3, 3. And none of these work because they need to be in the top left. And these are all in the top right. Here 624426. 624426, so it'd be this pair would work, this pair would work, then this pair wouldn't work because this thing's inside. So there's two ways there. 311311, 311311. So these two work, this one doesn't work. Okay. So I think this is something where we probably want some sort of n log n solution rather than n squared solution. Points, there's 50 points. Oh, there's 50 points. You could probably do an n squared solution in that case. Alright, I'm pretty sure that it should be done in n log n fashion. Like there should be some way of sorting it so that you don't have to compare a point to every other point. I don't think a linear solution would work here. I don't think that you need to be able to come up with some sort of ranking, I think. Some sort of sorting of it. Sorting how far in the upper left corner it is, maybe. So if you have a point and you have another point that is above it or to the left of it, doesn't work if it's above or to the left. Oh. Sorting it doesn't work. So here my idea is this would be pretty simple to make some form of n squared solution or O of n squared solution that compares that evaluates every possible pairing of points to see if they work. Actually, maybe that's not that simple. You can't have points inside that square or that rectangle that's formed. Oh, okay, so maybe I'm wrong with that. Did forget the second clause. What would make sense here? Do a point if you sort by the x coordinates. Sort by the x coordinates, then you know that the points are in some form of left to right. So you're guaranteed that the next point that you go to will at least be to the left. I guess you need to sort in ascending order for the x coordinate and descending order for the y coordinate in that case, because you want to use tie breaks to be the higher one and then the lower one. So if you sort by x coordinate, let's assume that that works without repetition of the x coordinate. Then if it has a lower y coordinate than the previous, if it has a lower y coordinate than the previous one, then it should be in the bottom left of the previous one. Huh, okay. It should be in the bottom right of the previous one. So the y coordinate after sorting for the x coordinate, the y coordinate is smaller, should be bottom right. So let's say it's something like 10, 0, 10, and then 1, 9, obviously that works. Then let's say it's like 2, 9, what happens then? So 2, 9 is going to be in the bottom left of, or bottom right of 0, 10. Technically is in the bottom left of 1, 9 as well. Then it's on the same, then 1, 9 is going to be in the same boxes. Same box as that. 0, 10, 1, 9, 2, 9. Then if you had something like 0, 10, let's say you had something really low. Let's say it was like 0, 1. So 0, 1 and 0, 10 are a pair. And then if you had something that was 2, 0, 2, 0, and 0, 1, those make up a pair. It'd be like a rectangle on the bottom area here. And it wouldn't necessarily conflict with something at the top. Ignore this. Like 0, 10 forms it with 0, 1, 0, 10 forms it with 1, 9, 0, 1 forms with 2, 0. 0, 10 doesn't form it with 2, 0 because it has 1, 9 in the way. 2, 2, 2. Huh. That's actually quite more complicated than I thought. So for each new point in the sorted list of points, the additional point needs to work with some number of the previous points. Work with some number of the previous points. And it also needs to ignore any of the points that previously could work with but have some points in between. How can I identify what points are in between? Maybe by doing some sort of transitive property. So if this point works with this one, and this one works with this one, by transitive property, this one would work with this one if this wasn't there, this middle one. But because this middle one is there, then it blocks it from working with anything that is in that area. Transitive property. Transitive property would block pairs from working. So, e.g., if A, B, if points A, if, example, where's our AB and BC, AC would normally work except B is in the way. So for two pairs of points, they either are in the correct position or they are in some form of incorrect positioning. So in correct positioning, they're either in the same horizontal, the same vertical. Yeah, 2 points in the same horizontal or same verticals work, right? And then if they are on this kind of downward sloping, their slope between the points is downward, is negative, then they would form a top right. They would normally be working. If their slope is positive, then they would normally not be working. Okay. Okay. And you want to have, so if there are 2 points on the same line, so if I were to go from here to here to here, because this one is working with this one already, then I can ignore this point when I'm dealing with this point. Maybe. I think that's right. So interesting. So maybe I have a stack. Am I returning the number of them? Return the count. Okay. Maybe I have a list of points in play. Points that are possible top left corners that are able to form a rectangle with further points in the list. Like for instance, if I had a list that was 1, 1, 2, 2, 3, 3, and then another point that was like 0, 5, 5, 0, 5, 0. These are all points in play that would form a rectangle that is not overlapping. Yeah, it's the list of kind of upper left corner points that haven't been hidden by anything else. But for instance, if I were to sort these, then the list would be like in this order, and then it starts with this point. This point forms the rectangle with this. And when it does, it pops it from the list because this point can no longer form rectangles with anything after it, because this one is basically hiding it. This point hides this point. That's right. So I need to compare. Is there a way to quickly evaluate the list? I guess the list is sorted by X then Y. Yeah, I think it's X then Y. Okay. Weights dot sort. Yeah. Okay. Answer is initially 0. And I'll have a stack. So I think I want something dummy on the stack so I don't have to always check if the stack is there. And whatever. Okay. So for every index, say k in the range of n, so the points of this thing would be x, y. Actually, I'd probably just use x, y in range of, or in the points array. While stack and top of the stack so if it has the same, so how's the stack going to sort? So if 1, 1, 2, 2, let's say there's another point that was 2, 3. Technically the 2, 2 would hide the 2, 3. I think. Not really. The 2, 2 would form with 2, 3, but it wouldn't necessarily hide it. Yeah, the vertical ones are going to be a little tricky. 1, 1, 2, 2, 2, 3. So 2, 3 and 2, 2 would form. 2, 3 and 2, 2 would form a thingamajigger vertical line. And it would form, that would be the only vertical line it forms, because anything below that would not work. And 2, 2 and 2, 3 would form. There's a point here, 2, 3. Then there's another thing that's something that's 3 high later on. That should form a horizontal and that should work. And that should pop that thing off the stack. But if it was something that was another thing that was too high, let's say 5, 2. 5, 2 should only be able to form with the 2, 2. Ugh. So 5, 2 would look at it and say that if there was a 2, 3 in the stack, that 5, 2 would form a rectangle with the 2, 3. and pop that off the stack. And then it form another rectangle with 2, 2. So it's not good. That is not good. So technically it shouldn't be able to form the 2, 2. So should I be looking at looking at the y in the reverse order? Like 1, 1, 2, 3, 2, 2, 1, 1, 2, 3, then 2, 2. So if it does 2, 3, that's fine. And then 2, 2, let's say that form it with the 2, 3. Form a rectangle with the 2, 3. It shouldn't remove the 2, 3 from the stack though. Because a later one that has 3 needs to actually compare it with this 3 and say a rectangle can be formed. I think the order is 1, 1, 2, 2, 2, 3. So then a 5, 3. Oh, so close, so close. So if I had a 5, 3, and looks at the 2, 3 and say, yeah, I can form something with that. So the issue is actually something more. Issue would be, let's say 1, 1, maybe 2, 2, 2, 4, 5, 2. The 5, 2 is in the bottom left, bottom right of 2, 4. Bottom right, bottom right, upper left, same thing. So 2, 4, 5, 2. That forms 1, then 2, 2 shouldn't be, 2, 2 should prevent it, or it needs to deduct from it. 5, 2, and 2, 2 normally would work. If you remove this, 2, 2, 5, 2 would normally work. The 2, 4 prevents it. Then if it was something like 5, 3, then the 2, 2 doesn't prevent it. So we pop the 2, 4 off the stack. What if I kept what if I actually kept track of things that I said were working? Okay. Yeah, what if I actually just had since it's so small, 50 by 50, what if I had what if I just kept track of that? So, and then I use the transitive property to block if there is already a tuple that's formed. But how do I know? How would I know? So like if I kept track of the index of the points, so like 1, 1, 2, 2, 2, 4, index 0, index 1, index 2, and then every time I see a pair that works, every time I see a pair that works, keep track of that pair. That still doesn't work, because then it'd be something like 2, if there was something like 2, 3 that blocks that pair. So if it was something like this. So 1, 1, 2, 2, 2, 3, 2, 4. The 2, 2 and the 2, 3 forms. The 2, 3 and 2, 4 forms. They're all still visible for later points that might be in the bottom left. Kinda. 2, 3. Oh. But also use some form of default dictionary. Maybe use a default dictionary where I keep track of the lowest what am I going to keep track of? So if I had a dictionary for the row, the x equals 2, x equals 2 as the key, and it maps to 2, 3, 4, maps to the y coordinates of everything with that x coordinate. Default dictionary of lists. And then for a new point would hide anything that is strictly to the top left of it. So I'd remove every point that was, strictly to the top left. But then all the points that are vertically or horizontally with it. All the points that are horizontally with it just wouldn't work. It has to be vertically with it, could still work. Since I'm moving left to right. Horizontally with it, if there was a point that was like 5, 2 and 2, 2, 5, 2 is strictly going to hide 2, 2 if I'm moving horizontally. If I have a bigger x value and a 2 or less y value, it should only form with 5, 2, not with the 2, 2. But the issue with the other one is, like I was saying, x value but different y values. There could be a point later on that has a y value that's between, like let's say this is 220 and 240, and it could be 530. So the y value could be between the y values of these. And then it would only form a single rectangle with the lowest, with the, not lowest, with the previous one that had a y value that was bigger than its y value. I iterate over the points, ascending order. What do I do with this? 2, 2, 2, 3, 2, 4. 2, 2, 2, 3, 2, 4. 2, 2 only hides 2, 3 if I'm dealing with something that's below. I'm dealing with something below 3. 2, 2, 2, 3, 2, 4. So if I'm dealing with 5, 2, 5, 2 pops this thing off, and it pops this thing off, and it pops this thing off. And when it pops them off, it's going to see that each of these is actually forming a rectangle, so it doesn't count them as additional things. Okay. I think so. So while stack and stack, the top of the stack would form something with the current xy points. Let's say top of the stack is top x, top y. This would form a rectangle, a valid rectangle. So the slope is negative is another way of doing it. So how do I want to do the logic here? So I know the x is going to be, the y needs to be less than or equal to, because it's already sorted. So while if the current y is less than or equal to the top y, then it would pop it from the stack for sure. It pops it from the top of the stack for sure. So answer should be plus equals 1. stack should be popped. And I think so could be it should pop off everything else that is on the same x and also with a y that is less than. So while stack and stack at -1, the x coordinate is equal to the top x, and stack top of the stack, the y coordinate is also greater than or equal to this points of y. Yeah, I think that's right. So if it was 5, 2, it would pop the 2, 4, pop the 2, 3, pop the 2, 2, but it wouldn't actually increment the answer in that case. And then stack becomes just 1, 1, and 5, 2. Oh, that's not going to work, is it? Actually needs the 2, 4. Even though the 5, 2 kind of hides the 2, 4 in some, if there was a thing in the bottom left of 5, 2, but then there's things that could be in the bottom left of 2, 4 that is not in the bottom left of 5, 2. Like 10, 3. 10, 3 wouldn't want the 2, 4 to be removed from the stack. What is the range of values here? Points are all distinct. The points are 0 to 50. Seems like it could be much bigger if it wanted to. But if it is constrained that way, then I think, I guess it should be for every height I need to track. For every height, it's going to form a rectangle with the previous element of anything that's higher that is not in vertical alignment with something that is the same height. That's not quite right either. As if it was 10, 0, then the 5, 2 does in fact hide the 2, 4. If this was in vertical alignment. Okay. Focus, focus. One. So if you had So if you had a bunch of vertical elements, I guess that's the main issue. Had a bunch of vertical elements. Any later one not on that vertical could only join with one thing on that vertical because of the blocking issue. But once it joins with one thing on that vertical, it would only hide anything on the same horizontal. So like 2, 2 and 5, 2. 5, 2 only really hides the 2, 2 from further usage. Because in theory, something could else end up being a 3 or a 4 that would form with these. Anything that's 2 height later on or less would form it with the 5, 2. So there's a hiding. You can hide early x coordinate on the same y coordinate. Hide an early x coordinate on the same y coordinate. For any x coordinate, there should only be one thing that forms. For any x coordinate, there can only be one thing that forms. I wonder if I can do this dynamically. Like if a point chains onto another point. Man, if only there wasn't the clause where you allow points to be on the same line. Make it, I think, a lot easier. Is my guess. Maybe it wouldn't. So if you have 1, 1, 2, 2, 3, 3, technically all those are kind of visible. You had a point that's like 5, 2.5. It would only form it with the 3, 3. It couldn't form it with the 2, 2. Or if you had a 5, 2, then it formed both 2, 2 and 3, 3. Or you had a 5, 1.5, form it with the 2, 2 and 3, 3, but not the 1, 1. So your y coordinates what if it was something like 2, 2, 3, 10, 4, 5. Yeah, 4, 5 even doesn't even hide 3, 10. Alright, I'm going to do the silly compare everything solution, and that doesn't work because of the hiding shit. Oh god. 1, 1, 2, 2, 3, 3, 3, 5. Go through the previous list. Go through the previous list. Three, 5. Go to the list of y values. This chains with this, and this. This thing works with this, and then you skip anything that it works with previously. For every point you have points that you worked with previously. This goes to here, and then this, let's say there was another point that was here. You work with that. Technically, it also works with that. This one works with this. This one works with this. So there was like an imaginary point here. This one will work with this and the imaginary point. And then go through here, testing this, then testing something here. So I'd be listing, it would do every other previous pair. Sets are just too big. Like, if this point, let's say this point C works with point B, then the set of all pairs that were previously working with point B needs to be excluded from further consideration for C. But then you're basically adding sets at that point. You're adding a set to another set. The set of all points that works with this thing needs to be added to the set to be excluded from this thing. So sort by X. Y's can be kind of randomly interpreted. Y's will fluctuate by sort by X. So low Y, high Y. So let's say X values were just something simple like 1, 2, 3, just increasing. But my Y values were like just random. So like 5, 10, 3, 4, or 3, 4, 5, 0, 11, 9, 2. So the Y's are just all over the place. So how many things can be formed? 0, 5, 1, 10, that doesn't form anything. And then the 2, 3 could form it with the 5, 0, 5, and the 1, 10. Since they're on not on the same vertical, they don't hide each other, or the same horizontal. Well, they can't really hide, they're not on the same horizontal because there are different x's here. They're different y's. They're not on the same vertical since they're different x's. 2, 3 with 0, 5 could form something. 2, 3 with 1, 10 could form something. Then if this was a 1, 4, then 2, 3 with the 0, 5 couldn't form anything because the 1, 4 is in the way. But the 1, 4 and the 0, 5 would form something already. Wonder. I'll take a break. This one I'm definitely gonna come back to and solve.